Hey, good afternoon to all. I'm Aditi Vashne and would like to welcome you all to this session where I will be talking about solid principle in automation. Let's move to the goal. The goal of the today presentation is to describe the solid principle in terms of building complex automation core framework with best practices. Let's begin. Before going to the agenda, let's see some knowledge etiquette. So first one is punctuality. You should always respect knowledge session timing. You are requested not to join session after 5 minute threshold. And most important thing that is a feedback. So make sure to submit a constructive feedback for all the session as it is very helpful for the presenter, and it can also help you to get better services in your future session like knowledge session. And the third one is the silent mode. Keep your screen on mute unless you have a query. If you have query in between of the session on any topic, so you can just unmute yourself and ask the questions. And the last one is avoid disturbance. So again the same one is like you should keep your screen and video on mute so that presenter is audible enough. Okay, so next move ahead to our today agenda. so uh, s- uh, as all we know that solid is popular set of design principle that are used in object oriented software development. We'll first discuss about the solid stands for. What do you mean by solid, and introduction to solid principles. And the next one are what are these principles, what do you mean, like what these deep and dive about the solid principles, and then why we use these principles in test automation. And the last one is benefits of these principle, and we'll conclude our session with a demo. So let's move to the first slide. Solid stand for. So S means single responsibility principle. O one is open close principle. L scope substitution principle. I is interface segregation principle, and D dependency inversion principle. These are the five terms of solid which stands for these terms. Okay, so let's move to the next. So yeah, so solid is an acronym that stand for five key design principles. The solid principle what
Maybe, are you sharing your screen?
uh, yes, it is already shared.
Is
Yeah,
it
it,
visible to everyone? Because I'm unable to see.
Yes, it
See,
is
it
Yes,
is
it is
visible
visible
from
visible
to
to
my
us.
us.
side. I would request you, in case if you're facing any network issue, kindly like refresh and try to rejoin. If can anyone else can confirm whether they are they are able to see the screen or not?
Yeah, it is visible to us.
Okay. Okay.
I continue.
Yeah, let me rejoin. Yeah. Okay. Thank you.
Thank you. So yeah, again, let me start with. So solid is popular set of design principles that are used in object-oriented software development, and the solid is an acronym that stand for five key design principles. The solid were developed by Robert C. Martin in 2000 essay that was design principle and design patterns. Although the acronym was coined later by Michael Feather. All five principles are commonly used by software engineers, and these provide some important benefits for developers. Uh, so uh, in like in Robert C. Martin essay, Martin acknowledged that success software will change and uh, develop as it's changed, it's become increasingly complex. Without good design principle, Martin warns that software become rigid, fragile, immobile, and viscous. So the solid principle were developed to combat these problematic design patterns. So this is the introduction about the solid principle. Now let's understand what is means S, and about deep and dive uh, the meaning of S. So, as single responsibility principle. So, Robert Martin summarized this principle well by mandating that a class should have one and only one reason to change. Following this principle, following this principle means that each class only does one thing, and every class or module only has responsibility for one part of software functionality. Means class only there will be only one reason to change the class. So let's understand the real life example. uh, when you are driving a car or bike, okay, so you want to fully concentrate on a single responsibility, right? So as per this, your responsibility will be driving only. So you don't want to do or concentrate your focus on other tasks like talking on a phone and eating. So it will really cause an injury for the for you. So it means it is stated that so there will be only one responsibility for a single class. I think hope you guys can understand this principle through real life example. So let's move to the examples of which will be used in the uh, automation. So yeah, as page object framework implement SRP very well, as we are going to have one class responsible for only one web page in the application. We shouldn't have a very big class with many responsibility like test method, UI action method, and Excel read and write method. Similarly, we can have very specific helper classes like Excel helper, database helper to work with Excel file or database to implement the data-driven framework. So we just try to make the classes very concise so that there will be no there will be no extra things so that it will be easy to maintain. Similarly, Selenium API has browser-specific driver classes like Firefox driver, Chrome driver, Internet Explorer driver. Firefox has single responsibility to drive Firefox browser, and it drives the Firefox browser very well. So these are some automation examples which we use in our test automation, and we should use these in our test automation. And now next one is open closed principle. So it's time for in solid known as open close principle. Software entities should be open for extension but closed for modification. As it also we can say the design and the writing of the code should be done in a way that new functionality should be added with minimum changes in the existing code. Only and the design should be done in a way to allow the adding of new functionality as new classes, keeping as much as possible existing code unchanged. So the closed part of the rule stated that once a class has been developed and tested, the class code shouldn't change except for any work fixes. And the open part of the rule stated that you should be able to extend existing code in order to introduce new functionality. So we are trying to add new functionality without modifying the existing code functionality and by adding new classes or code as required. So this is very important to minimize the impact of changes and error from existing code. So I let's understand the daily life example, how we can understand this from a one example. So let's say you live in a two-bedroom house, and you are looking for three-bedroom house due to reason like growing childrens and all and growing family. So if you have free and unused space available, so it's very easy to extend the house by building another bedroom, right? But also with this, you are minimizing the impact of changing on the existing two-bedroom house. And so I think you guys understand this. I hope you'll able to understand this principle by a real life examples, right? And next is examples of closed principle, open closed principles in our coding style. So let's say you are automating an online store application, and you have customer class to represent store customer and respective related customer actions. Now your company has introduced VIP customer concept to reward loyal customer with discount and free delivery. Okay, like in Amazon and Amazon Prime members, right? So to implement VIP customer behavior in your automation, so open close principle suggests that keep the customer class same without modifying it, and create a new VIP customer class by inheriting from customer class. Now in the VIP customer class, extend the behavior as required. So we don't need to uh, uh, change the existing code. We are just inheriting and extending the code. So it is open for like mo- uh, extend closed for modification. It is open for changing. So I'll explain it in a demo also with the coding style. So now let's move to the next principle. Yeah, Liskov substitution principle. So, this principle is introduced by Barbara Liskov, stated that object in a program should be sorry, rep, replaceable with instant of their subtype without altering the correctness of that program. Also, if a program module is using a base class, then reference to the base class can be replaced by with a derived class without affecting the functionality of the program module. We can also state that derived type must be substitutable for their base type. So, let's understand the same principle with a real life example. Let's say you have a wall clock at home, or a wristwatch. So they both work the same. Like you are able to check the time on both. So they both need a battery to work. Okay. So if you buy batteries as per their specification from any brand like Panasonic, Sony, any brand like Duracell, so you expect the wall clock or the wristwatch to work properly without any issue when powered by those batteries. So both will be work using the same battery. And I will give a brief about this principle in demo as well. So we are able to understand this um, using the coding style. Okay. So now let's move to the next principle. There is some examples I have added. So let's consider the example of same automating an online store application with customer and VIP customer category. Let's say there is a method called calculate delivery charge. So we have the arguments customer and order info, which calculate delivery charges when customer and order information is passed. Okay, when we pass customer object to the calculated delivery charge method with order information, it should return delivery charges. Note that we are providing free delivery to the VIP customer, as we are doing earlier. So when we pass VIP customer object for customer argument to calculate delivery charge method with order information, the program or code should work properly without changing its behavior and should not throw any exception. So this is a coding example. I will explain the same in the demo. So the next one is interface segregation principle. So as many it is stated that many client specific interface are better than one general purpose interface. So mm, as we know, we should we should create a small interface rather than a big interface, as we should not enforce client to implement interfaces that they don't use. Instead of creating one big interface, we can break down it into a smaller interface. As sometimes we know that we have created a number of methods in the interface, and we are not using those interfaces in other interfaces. We are not able to use those, so it will create a confusion as well, or why it is created. So we should create a very concise or very small interfaces rather than creating a big interfaces. So let's understand the same with real life example. So when you are traveling in a train, and when ticket inspector wants to check your ticket, so you will showing only your ticket, not your luggage. Even you have all the things with you, luggage, tickets, and many much things. So similarly, ticket inspector want to check your ticket, not only the other belongings. So we should expose only what required for the given task. We are not showing the unrequired things. Okay, so let's understand the same with code example. Like Selenium API is good example of ISP. Selenium API has number of very fine-grained role-based client-specific interface like WebDriver, WebElement, Alert. So we should favor role-based interfaces instead of generic interfaces. And the next one, last but not least, so the last one is dependency inversion principle. So simply, one should depend upon abstraction, not concretion. So simply put, that developers should depend on abstraction, not concretions. Martin further explained this principle by asserting that abstraction should not depend on details. Details should depend upon abstraction. Further, high-level modules should not depend upon low-level module. So both should depend on abstraction. So these line stated that if a high module or a class will depend more on low-level module or the class, then your code would have tight coupling. And if you will try to make a change in one class, it can break another class, which is risky at the production level. So always try to make classes loosely coupled as much as you can. And you can achieve this through abstraction. So the main motive of this principle is decoupling the dependency. So if a class A changes, the class B does not need to care of know about the changes. So this is the dependency inversion principle. Let's understand the same principle with a real life example. So when you go to the ATM machine or cash machine, so the machine accepts a valid debit or credit card, right? So the machine has a dependency on a valid card abstraction, and not on the specific concrete types cards, like it's a Visa card, it's a Maestro card only issued by a specific bank. So the machine works for any valid card type implementation, and we are providing the card to the machine from outside, which provides so much flexibility and easiness to use the machine. So here it depends on the abstraction, not concretion. So let's understand the coding style with the in the demo only. Okay, so now let's understand why we use solid principle in test automation. So the broad goal of solid principle is to reduce dependency so that engineers can change one area of software without impacting others, right? So, like any development work, automation also need to be planned, designed, developed, maintained, and extended over the time. Our automation code or automation framework is an application which is testing our actual application. That's why solid principles are highly recommended for our automation to make it easy to understand, use, maintain, and extend over a time. So when solid principles are not applied, our automation might become fragile, hard to maintain, and hard to extend very soon. It helps us to write testable code by using good design principle. So I have found that while developing software using TDD approach, designing the application using the solid design principle result in fewer overall tests that better capture the behavior of the application. So it so these are our benefits. So why we use the same in the test automation? It really helps in fast maintain reusable code and faster compilation as well. So next, move to the benefits of solids. So first, the let's understand the benefits of single responsibility principle. First one is testing. So a class with one responsible will have far fewer test cases. So we are able easy to testable, like we are able to write test cases easily and able to test it. Similarly, lower coupling, like less functionality in a single class will have fewer dependencies. There will be no dependencies, it will give us a lower coupling. And organization, so yes, if we have a small class, so we are able to organize them very easily, and if we want to search anything, so it is easy to search than a monolithic ones. So these are the solid benefits of single responsibility. And the benefits of open close principles. So the benefits of adhering to the open close principle can potentially streamline code maintenance and minimize risk of breaking the existing code. As we know, like if we don't need we are not changing the code, we are only adding or changing the we are not changing the existing code, we are just extending the code, so it will really break the risk of breaking the existing code base. Similarly, one benefit is that programmers do not have to reinvent the wheel, like they don't need to reinvent the whole application if they can extend upon the behavior that have already been defined. And only new changes need to deploy instead of entire code base in the protection. Like if something is breaking or something is there buggy, if there's a buggy code, so he just need to deploy that buggy code instead of in whole application or whole code. Similarly, the software entity should be closed for modification, because making changes directly to those entity may result in unwanted bug in the system. These are the benefits of open close principle. And benefits of list scope substitution principles are: code that adhere to LSP is loosely dependent to each other. Like if like the object of parent class can be easily used in the child class, so they are loosely dependent to each other and encourage code, so we are able to use reuse the code easily. And benefits of interface segregation principles are faster compilation and maintainability, and the reusability. Like if you have violated ISP, like stuff matter together in the interface, and when method signature changes, you need to recompile all the derived classes. So this is an important aspect for some compiled language, which is very well known for slow compilation, while another way around is self-explainable. So, and the maintainability, Martin also mentioned that fat interfaces like interfaces with additional useless method lead to inadvertent coupling between classes. So thus, an experienced dev knows coupling is best for reusability, and mm, it is much more maintainable when we have a small interface. So we are easily maintain these interface easily. So next, benefit of dependency inversion principle. So finally, dependency inversion principle, when applied correctly, give us the flexibility and stability at the level of the entire architecture of our application, and our application will be able to evolve more securely and become stable and robust. So we should follow these principles for a good framework, and for a flexible framework, for smaller and maintainable framework, right? So I hope you guys are able to understand these principles and the use of these principles in our daily life, and in our daily while creating a framework. uh, so let's move to the demo part. uh, so I will understand the same principles using a demo. Okay. So let's understand. I have created one code here. We have a marker. Okay. So marker have name, color, or price. Okay. So if I have created a class of marker, so I have created this object. Okay. So I have added all the things in one class. Now what I want, I need to create the invoice of the marker. And there are I have added marker and a quantity. So there's a formula how I can create an invoice, the how many marker and the price of marker. So I just multiply the same, and we can get the price. And I have added the same, we need a invoice, so we are printing the invoice and we are save the same in the db. So I have added all three methods in a same. What happened, in the single responsibility principle, uh, if it is stated that there is only one reason to change the class, but what there are how many reasons are there in, can anyone like explain, tell me how many reasons are there in this class to change? Like I have added three methods here: calculate total, print invoice, save to DB. So what are the reasons, we can change, how many reasons are there we can change our class? I think it's a really very basic questions, but no problem. Let me tell you. So eh, first is, if I will add the GST or some tax, so the formula will change, right? So it will not price and quantity, it will give us uh, uh, the total amount of the marker. So there is one reason. And another one is print invoice. I'm printing this invoice. So if I am not printing, there will be a different way to printing, and the implementation will change. So there is another reason. And similarly, we are saving the invoice in a db. But in future we want to save in a file, we want to save in a different type of db like mongodb and other db. So there are three reasons to change this class. uh, so it not follow the single responsibility principle, right? So what should we do? We should create a different class for a different for these three different method. Like I have created the invoice save class. It will mm, save the invoice in a db. So if anything will change. So there will be only one reason to change. Like if I have to save a db in a invoice in a db in a file in a, so I can add the implementation there. So there is only one reason to change. Similarly, I have created a another class invoice print. So if I have to print in a different way and want to change the implementation, so we can easily change. So by splitting the class, or by giving us with a small class, we are able to manage the code easily, and it looks good as well. So we are following the single responsibility principle. I hope you guys are able to understand through this code, right? Now let's move to the open close principle. So take the same example, right? So I have this example invoice. So I am just saving the same to the db. Okay. And now the things are changed. Like I am changing it, uh, as open close principle is stated that open for modification, closed for sorry open for extend, and close for modification, right? So extension is open, and modification is closed. So here I have one class which save the invoice to the db. Okay. Now I want to save a file, save the invoice in a file. So I have extended this, um, I have added the another method in the same class. But it is not to what happened, like this is already tested, this class is already tested and live. Okay. But now the client required to client requirement is changed, like he want to save the same in a file. So what we do, we'll just open this code and just add the another method. Okay. So again we need to do what we need to do, we need to interfere this class. Okay. But it is already live and tested, and if we add more method and we'll modify it, so it will create some bugs as well. Okay. So what we do, will not doing like this, we'll create an interface. So it is a separate interface. So we'll create an interface so that we can extend the things, and in the future as well. Like if in the future we want to save in a file, so we are able to implement those classes, are the sorry implement those interface which is already created. We don't need to touch the already live and tested interfaces, right? So I have created like this. Okay. So I think is there is any doubt, guys? If you have, you can ask. Okay. And I think it is clear to you guys what is open close principle, and we can use the same in our coding style. Next one is the scope substitution principle. As stated, we the child the child class can use the object of parent class easily without changing the program or without affecting the program. So I have created a interface of car. Okay. So I have created two methods here, turn on engine and accelerator. So if I am using the like if I have implementing the same interface in a motor car, so I in a motor car I have the engine. Okay. So it will work like turn on engine and accelerate it. But what if I will implement the same in a bicycle, so it will not for because we it will break the code, right? Because bicycle don't have the engine, and so it will break the code. So it is not a good program. It is not following the scope substitution principle. So we should not write such interfaces or other methods which is not used by his the object of the parent class should not be used in the bicycle child class. So we should not follow this, right? So this is all about the list scope substitution principle, and the next one is interface segregation principle. As stated, we should create a small interface rather than a big interface, or we should the client should use the mm, same small interface, not the big one. So here let's understand this with an example: restaurant employee. So restaurant, what employee can do: we wash dish, serve customer, cook food. So I have these three methods I have created in one interface. So if waiter implement this restaurant employee class interface, so what are so he this class should use all the three methods, right? Wash dish, serve customer, cook food. But here waiter has no job for wash dish, it is not his job to wash dish. Similarly, it is not job to cook food. The job of the waiter only is to serving the customer. So that's why these two methods are not in used in this class. Okay, so that's why I have created the small interface. Like I have created a different interface like waiter interface, which only do serve customer and take order. Similarly, chef interface, cook food and decide menu. Similar, and helper interface, which washes dish. So now we have just break this large interface into the smaller, so that the unused code should not be there. We are able to use only the usable method, use method, not unused. Okay, so next one is uh, dependency inversion principle. Okay, so let's understand this example. I have a window machine, okay, and I have two object in the window machine. Like I have wired keyboard and wired mouse. I have created this as a wired keyboard, as a wired mouse. And But what happened if in future I don't have the wired keyboard and the wired mouse? So these are the concrete I have created a concrete object. As dependency inversion principle stated that do not create a concrete, create the abstraction. So here these are if I'm going to use the same in the keyboard interface. So I have created these objects like wired in a concrete method. So in a concrete way. So we should use this we should declare this as like this. So no, only the keyboard on the or the mouse. So I have created a constructor like this, and so that we are able to use these methods in a concrete manner. So this is all about this dependency inversion principle. uh, and I hope you guys are able to understand this, and if you guys have any questions, so you can ask.
If anyone has any question, please tell here.
So, do we have any questions from our side? Uh,
So
I
I
think,
believe, yeah, yeah,
yeah,
Shashma, please go ahead.
Yeah, so I was just saying that I think we can again revisit the topic, and if we have anything from our side, we can like mail or ping Aditi regarding the topic. And it was a very nice session, Aditi. We were able to like get very much insight about the solid design principles, whatever you have taught us. So we really want to just go back to the topic again, and I think we are fine with this. Thank you so
Thank you
much,
so much,
Aditi.
Aditi, for such a wonderful session. Thank you so much, everyone, for joining in. So I'll be ending this meeting for everyone. Thank you, everyone.
Yeah, thank you so much for joining the session. Thank you. Bye bye.